All right. You'll be able to see the slide now. If you can't, let me know. This is our 43rd lesson on the biblical flood. Marion Fox teaching the class. We're getting it, we're deriving this material from the second edition of my book, The Biblical Flood. Last week, we looked at lakes, Lake Bonneville and some other lakes. And we looked at them and how that when they overflowed, all of a sudden began to cut deep channels. The lakes dumped their water into the oceans. And of course, this removed the weight of the water from the landmass. And so the landmass was elevated due to isostasy. That is, it adjustments. And isostasy is very easily seen if you step off a dock into a small boat. You can actually sense the boat sinking a little bit into the water due to your weight. As you step off the boat onto the dock, the boat will elevate. That's change in isostasy. And basically, we have basic, simple principles of physics. Now, the fluvial lakes, when they cut channels, Bonneville cut channels through the various river basins and cut channels to drain the Bonneville Lake and also make Lake Missoula the glacial lake and other lakes of like nature that we looked at last week. The number of lakes, when they drained, they would elevate the ocean levels, and that would, of course, put extra weight on the bottom of the ocean, the floor, and push it deeper into the magma and allow the continents to be elevated. So there were adjustments in isostasy. When this occurs, this will cause volcanoes in some instances, and also, of course, earthquakes. Just as an illustration of this, when they built Hoover Dam or Boulder Dam on the Colorado River in the 1930s, the dam that was built, as it began to fill up with water, they began to have small earthquakes all around that area. They increased gradually. Just as the water began to fill it, the earthquakes began to increase. And after it became full, they continued for a few years, then they died out pretty much. And of course, this is adjustments in isostasy. That's exactly what happened. And of course, this would happen on a much greater scale because these lakes were much, much larger than the lake impounded by Boulder Dam. So the fluvial lakes and glaciers melting and putting their water into the ocean, the sudden drainage of these lakes elevated the levels of the oceans, and the calving of glaciers, that's where pieces of the glacier break off, elevated the levels of the oceans as well. We see also something called Heinrich Events. These are first described by the marine geologist Hartmut Heinrich. And Hartmut Heinrich occurred during the last glacial period or ice age. Of course, this is an atheist, we're quoting from an atheist. During such events, armadas of icebergs broke off from glaciers and traversed the North Atlantic. The icebergs contained rock mass eroded by the glaciers, and as they melted, this matter was dropped onto the seafloor as ice rafted debris. This drilling through marine sediments can distinguish 6 distinct events in cores of mud retrieved from the seafloor, which are labeled H1 through H6. That'd be the Heinrich Event 1 through Heinrich Event 6. Going back in time, there's some evidence that H3 and H6 differ from other events. So what I'm saying here is the glaciers that were deposited during the flood, these glaciers, as they melted and moved across the oceans, dumped their rocks that was in the glaciers, in the ice, and they dumped them on the ocean floor. And that's what we're seeing here with this. And they have 6 different events. Of course, if that's true, then there probably were 6 major things, such as the drainage of large lakes, Lake Agassiz, and other lakes of that nature that we saw earlier in the last class. And if these very suddenly dumped large amounts of ice into the ocean, then this would have deposited these rocks or these stones that were rafted in glaciers or embedded in glaciers. Some scientists think the Heinrich events affected the thermohaline circulation patterns of the ocean, but we won't look at that any further. Some glacial lakes were formed by moraines. And we talked about moraines last time, and I will have some pictures of some. That's earth and rock dams formed when the glacier pushed, or we could say like a bulldozer, bulldozed the soil and rocks into a mound. Some glacial lakes, and I got it misspelled, were formed by the ice of the glacier. So some glacial lakes were formed by the ice. So there are ice dams as well. The next 2 slides show these mechanisms. If you look here, you can see as the glacier is pushed, and this is like a dam right here. So it's pushed up here. We see them also over here, other places. That's a moraine, called a moraine. Here's another moraine right over here, and water comes from the glacier and melts and comes down, and it fills this lake here, this glacial lake. Now, if this water fills up this lake sufficient, it overflows this moraine. The moraine is not packed. If you make a dam, an earthen dam, they have to pack the dirt real good. Otherwise, the water will begin to seep through it, and it begins to seep through it, it'll cut a hole through it and breach it. And the water, then the water of the lake will flow out and cut the channel through this moraine. And so that'll happen. And if it's not packed real well, it'll start seeping down here to the lower levels and eventually cut a hole through it. So these moraine lakes eventually will cut a hole through that moraine unless there's rock there to keep them going. Here's an ice dam. We saw this at Hubbard Bay in the last lesson. Here's a moraine as well, a combination with ice that dammed this up, and they actually saw this, and we saw the pictures of it in our last study, in our last lesson. Now, in Mediterranean Sea, here's another situation we run into. We're going to consider the effects of the rising sea levels on the Mediterranean Sea and the Black Seas. What a lot of people don't realize is that the Mediterranean Sea has more evaporation than it has river water flowing into it. So the water from the North Atlantic Ocean flows into the Mediterranean Sea. The Straits of Gibraltar have a flow of water from the Mediterranean and from the Atlantic into the Mediterranean Sea, because there's more evaporation from the Mediterranean than there is water flowing in through rivers. And consequently, sailing ships used to have to get a real good east wind to breach or go out of the Mediterranean through the Straits of Gibraltar. Of course, diesel-powered ships and steam-powered ships didn't have to, because they could go against the flow of the water. But the flow of the water into the Mediterranean Sea is like 1 or 2 miles per hour. It's sufficient to be a little problem for a ship unless it has a tailwind, a sailing ship, that is. What we're going to see is we're going to look at the Mediterranean Sea and the Black Sea, as well as to some extent the Aral Sea and the Caspian Sea. But we'll just look at them briefly. There's good evidence that the Strait of Gibraltar was a land bridge, was an isthmus, and that it crossed and blocked the flow of water after the flood into the Mediterranean from the Atlantic Ocean. The Mediterranean then was not tied to, wasn't linked in with with the Atlantic Ocean at that time after the flood. That was bridged by land after the flood. And what we see here, here's the Strait of Gibraltar. And this, what I'm claiming here is, and I believe there's good evidence for it, that this was a land bridge across here after the flood. And the Mediterranean, of course, doesn't have enough water flowing from rivers to keep it replenished, and it began to diminish in level. As the water evaporated in it, it rained out to the east over here and went into the oceans. The ocean levels began to rise. They were also rising from other mechanisms, the fluvial lakes draining, such as Lake Bonneville and Agassiz and so forth, Lake Iroquois, and then the big lakes up in Siberia and Russia and northern Russia, and other parts of the world that we looked at last week. These would, and the glaciers melting, all of this in combination would have raised the North Atlantic sea level several hundred feet. We've already seen this with further evidence of it, and that would have breached this land bridge across here. And when it cut through, then it began to fill it up. So that's what I'm claiming happened, and I believe we have sufficient evidence to see that. This perhaps would be linked in with the situations that occurred in the days of Abraham and in the days of Jacob when he went down into Egypt. Abraham went down into Egypt at one occasion, the famine that occurred. Famines could occur because of droughts, but they can also occur because of too much rain or even infestation of insects can cause famines. So to say there was a famine doesn't mean it wasn't necessarily a drought, but it could be a drought, and that might be the linkage. I haven't gotten sufficient evidence for me to take a stand on that, but I'm thinking it might be linked with it. I need to study that further. In a shoe.
Marion?
Yes.
We're having trouble with the screen. Can you see if your screen's working? If you're sharing that picture with us?
Well, I'm sorry. Let me back out of it.
That's good. Thank you, sir.
Yeah, we see it now, but we don't see. You need to go into slide mode, presenter mode. But that's better. We lost it. I thought it was mine, but other people are having trouble too.
Can you see it now?
Yes.
Yes.
Okay, I'm going to start over from scratch. All right. All right, we'll just start all over. All right, can you see it now?
Yes.
Okay. All right. What we'll do now, this is our 43rd lesson, and we'll continue and link this in with the fluvial lakes that we had last lesson. Fluvial lakes and glaciers, when they melted, they elevated the sea level. And in the elevation of the sea level, they created situations that we're going to see here with the Mediterranean Sea and some other places in the world as well. Sudden drainage of the fluvial lakes and glacial lakes elevated the levels of the oceans rapidly and would create a rapid rise in the ocean levels. Some of these lakes were very, very large. We see this. Also, the calving of glaciers, with pieces of the glacier breaking off, elevated the levels of the oceans as well. Now, we find something called Heinrich Events, first described by the marine geologist Hartmut Heinrich, occurred during the last glacial period or ice age. During such events, armadas of icebergs broke off from glaciers, traversed the North Atlantic. The icebergs contained rock mass eroded by the glaciers, and as they melted, this matter was dropped onto the seafloor as ice rafted debris. So we see the rocks then in the ocean itself. And the scientists drill through marine sediments. When they're drilling to them, can distinguish 6 distinct events in cores of mud. retrieved from the sea level. They're labeled H1 through H6 going back in time. Some evidence that these H3 and H6 differ from the other events, but we'll not look at this any further. What I'm claiming is that this would have been ice rafted rocks, and as the glaciers broke off that were deposited during the flood, it would have rocks in them, and they would just float down in the North Atlantic and drop the rocks. So it's no problem. It fits my model quite well. Some scientists think the Heinrich events affected the thermohaline circulation patterns of the ocean. We won't look at that. Not to get off on that because of time. Some glacial lakes were formed by moraines. That's earth and rock dams formed when the glacier pushed or bulldozed the soil rocks into a mound. And we're going to take a look at some glacial lakes that were formed by ice as well. So ice itself could form a dam, as we had in Lake Missoula, and of course we could have moraines forming them as well. The next two slides show these two mechanisms. Here's a moraine. If you can see my mouse moving across here, as the glacier pushed debris, soil, generally speaking, and it would grind, as the glacier moved across rocks, it would grind off pieces of the rocks. And this would be part of this moraine. Now this would form a dam here, but this material is not packed. Like an earthen dam has to be packed real good, real heavy weights put on it to pack it, make it firm so it won't leak through. We also have, here's another moraine. Here's a moraine lake right here. Here's a moraine lake, and of course the glacier moves and melts and goes down into it. Even pieces of ice come down into it. Here's your moraine. Now this moraine is relatively soft material. If you build an earthen dam, they have to pack it real good. Otherwise, the water will begin to seep through this loose soil. And as it goes through, eventually it will kind of loosen the soil, and finally it begin to flow through it. And then, of course, once it starts flowing through it, then pieces of it begin to fall in, and they move down and flow down with the water. And eventually the whole moraine is breached, and the lake itself will drain out, unless there's some rock or something real firm underneath to stop it. So this moraine would eventually be breached because it's not packed real well. An ice dam and a moraine combination, as we saw last week at Hubbard Bay, Alaska. We saw this and looked at this in some detail last week in our last class. We're going to consider the effects of the rising sea levels on the Mediterranean and Black Seas, but also bring in the Caspian and Aral Seas just very briefly, however, because they were at one time apparently linked to the Black Sea. There's evidence of that. There's good evidence that the Strait of Gibraltar was bridged by land after the flood. In other words, that the Atlantic Ocean and the Mediterranean Sea were not tied or not linked together. Here's the Straits of Gibraltar, and what I'm claiming, and scientists are claiming, even atheists, that across this there was a bridge, an isthmus, and that there was no tie-in, no linkage, no water flowing out of the Atlantic into the Mediterranean. Now, what we know right now is there's not enough water flowing into the Mediterranean Sea to replenish the amount of evaporation. In other words, the evaporation rate is much higher than the inflow of water from rivers. And so water flows from the Atlantic into the Mediterranean in this direction from west to east. And so there's a flow of 1 or 2 miles per hour of water flow through this Straits of Gibraltar. Old sailing ships had to get an east wind to get out of the Straits of Gibraltar. I think the Greeks called this the Pillars of Hercules. But the sailors had to get an east wind to be able to get out into the Atlantic Ocean. Otherwise, they'd sit here and the flow of the water would push them backwards. So this water flows in. So what we're going to see here is some evidence that this was once, that the Mediterranean Sea once dried up. I believe it dried up. It was filled with water after the flood and began to dry due to evaporation after the flood. That it dried out and the Black Sea filled up, Aral and Caspian Sea filled up. Then they breached the Straits of Bosporus and flowed into the Adriatic Sea and the sea on the east side of Greece, between Turkey and Greece, and into the Mediterranean, and partially filled it. And then eventually it evaporated again. And then the levels of the ocean were rising due to the fluvial lakes draining into the ocean and the glaciers melting. So this level of the sea level has been rising ever since the flood, pretty much. Now, what we find is, as this water evaporated, it would flow and as rainfall and dump into the Indian Ocean, primarily most of it, and it would flow mostly into the Indian Ocean. As it did, it would raise the ocean levels several feet, about 40 feet, 40 or 50 feet. And then eventually, when this Straits of Gibraltar were breached, it lowered the ocean levels about 40 or 50 feet to fill up the Mediterranean Sea basin. So there is evidence of, there's archaeological evidence. We'll see that in just a few minutes. So I believe this happened right after the flood, not immediately, several hundred years after the flood, maybe 1,000 or so. It was perhaps around the time of Abraham. It might be linked, I don't know for sure, I have no evidence of this, but I think it's possible that it was linked with the time that Abraham went down to Egypt when there was a famine in the land. Famines can be caused by droughts. If the Mediterranean was drying up, it wouldn't give as much rainfall in that region of what we know as Palestine right now, or the land of Canaan, better biblical term, land of Canaan. Also, there might have been the elevation of it to the Black Sea dumping in, elevated it a little bit, and then it went back down, maybe in the times of, perhaps in the time of Joseph, and going down into Egypt. So again, this I'm kind of shaky on. I'm not sure about this. I haven't done enough research to determine whether that's true or not. It might be, though. Mediterranean Sea, Kenneth Shue contended that the water in the Mediterranean basin evaporated and that the basin became a desert. I'm not sure that he's entirely correct, but a large portion of the basin probably did become a desert during this period of time. Stanley claimed it didn't fully dry, but that it was greatly lowered, and Stanley's probably close to the truth. Shue was probably not saying it was totally a desert, but that there were sections of it that were desert, and they would remain desert because they'd have a lot of salt in them, and so they wouldn't be very good for farming or for plant life to grow. Matthews concludes, now these are all in chapter 16 of my book. I'm going to move chapter 16, this part of it, into chapter 11, right after the fluvial lakes discussion of them. Matthews concludes that the Mediterranean basin was a desert which was refilled by the breach in the Straits of Gibraltar. That's page 21 of his. Matthews also states the entire refilling may have taken only a century. It would have dropped the world sea level about 40 feet. Well, if it dropped the world sea level by 40 feet, the evaporation of it would have raised it about 40 feet. So the water transferred through evaporation and rainfall into the area, probably into the Gulf of, well, some of it would have gone to the Arabian Sea, over into the Persian Gulf. Most of it probably would have gone in that region, the rainfall. It could have gone further east, even in China, the water from evaporation, in which case it would have gone into the Pacific Ocean. But this refilling, since all the oceans are connected, they would have, their level would have moved the water around. The entire refilling, however, if it lowered the sea level 60 feet, 40 feet, then whenever it was evaporating, it would have raised it 40 feet. So it would have whipsawed back and forth by plus 40 and minus 40, a total of 80 feet change in the value, in the levels of it during this time. In fact, there's archaeological evidence that the Mediterranean Sea was lower than it is at the present time. We're going to show this evidence. 1985, Heinrich Conqueror, my French is not very good, a professional deep sea diver discovered a narrow underwater opening, barely 9 feet by 3, beneath the base of a cliff rising from the Mediterranean Sea, located in the Calanak area between Marseille and Cassis. The cave was 110 feet below sea level. Now, what did they find in this cave? These men claim that the evidence tells us that ancient people went into the Cosquer cave during at least 2 different periods. During Paleolithic times, the sea level was about 306 feet lower than it is now. Well, how do they know that? Well, apparently there's other evidence. And the coast was several miles away from the cliff. And so we're out here now. This shows that the sea level was much, much lower, 360 feet lower at least. And so we see the change in the sea level during this time. There's not a sufficient amount of water supplied by the rivers to drain into the Mediterranean Sea to replenish the water that evaporates. The evaporation rate is higher than the inflow through rivers. Cloud states, and again, all of these quotes are in chapter 16 of my book, the annual of the first edition. They'll be in chapter 11 when I reprint it. The annual loss of water by evaporation by the Mediterranean surface today exceeds by 3 times that added by all its tributary sources plus rainfall. So if you have the rainfall and the inflow of water, the evaporation is 3 times what you have flowing in. So you have to have inflow of water to keep it going, or it will dry up. And that, of course, flows through the Straits of Gibraltar, as we've seen. There's evidence of extensive evaporation of the Mediterranean. The evaporation of salt water will make it, there'll be more salt. And those minerals that are there after it evaporates. Geoscientists have discovered 3 lakes of extremely salty brine lying in pockets on the floor of the Mediterranean Sea. So in the deepest areas, there's this real salty brine lying in pockets. And oceanographers have previously identified 2 other brine lakes in the Mediterranean during expeditions a decade ago. It's in Science News, page 157. And again, the actual site is in chapter 16 of volume 1, the first edition, rather, of my book. Wallman states, we calculated the time taken to generate the measured profiles using a simple one-dimensional transport model. So they're using a simple transport model. Our calculation indicates that the surface sediments have been in contact with magnesium chloride brine. And so there's magnesium and chlorine in it, and for over 2,000 years. Within this short period, now see, it's over 2,000 years. And of course, we're 2,000 years away from the birth of our Lord. So they're looking back only to the time of Christ for this. Within this short period, the Discovery Basin must have been filled at an average rate of 10 to the 5th cubic meters per year, 10 to the 5th. That's 100,000 cubic meters. And so that would be a cubic meter would be 1 meter by 1 meter by 1 meter. So it's a cube, and a meter is 39.37 inches, a little bit bigger than a yard. This is probably about nearly 10 times that many cubic yards, 10 to the fifth, 100,000 cubic meters per year. That's quite a lot of material. And so the sediments, that's just sediments. That's not water, it's sediments. Rauschy and St. Martin have a quote of them. According to major biological contributors, and despite minor fluctuations, two main intervals of sedimentation separated by a sedimentary gap may be distinguished. So they come up with the evidence of two main intervals of sedimentation. And that fits my model because my claim is we'll lay it out as we get my model here. We're going to take this information and put it together and set forth what I believe, I'm convinced happened. And I'm just looking at the evidence and tying it together as best I can. Records of the later Neogene history, moreover, are not limited to the Mediterranean. So he says this is not limited to the Mediterranean. So this ties in with how there were two of them. The evidence is extended by drill cores from the bottom of the Black Sea basin. When the Black Sea and Mediterranean basins were separate, at one time they weren't tied together. They weren't. The water didn't flow out of the Black Sea into the Mediterranean as it does now. So we didn't have water flowing from the Atlantic into the Mediterranean at one time. We didn't have water flowing from the Black Sea into the Mediterranean at one time either. So when the Black Sea and the Mediterranean basins were separate influx from the Danube, and he gives three other rivers and other Central and Southern European rivers, these are the big rivers, transformed the Black Sea to a freshwater lake. So it was made into a freshwater lake. Now it's a brine sea now. It remained so until the first desiccation of the Mediterranean, which when reorganization of the European drainage basin diverted much of the Black Sea tributary water to the Mediterranean, accounting for local eastern Mediterranean sediments with distinctive non-marine microfossils. Now, marine fossil would be something from saltwater, and aquatic fossil would be something from freshwater. So that's the difference when it says non-marine microfossils. So the Black Sea at that time was a freshwater lake. That's what they're claiming. It's a brine lake now. Birkeland and Larsen state not only were the Aral and Caspian seas larger in the recent geological past than they are today, but they were connected with one another as well as with the Black Sea. So all of these were connected together in the past. And again, there's sufficient evidence to back that up. I believe these lakes were filled with melting ice. That the ice was dammed in the north and flowed into these lakes, filled them up with ice water. That'd be fresh water, of course. Now, here's what we see: the Mediterranean seafloor. It's just a map of the seafloor, and what we see over here is the Black Sea. Here's the Straits of Bosphorus, and the Dardanelles Straits right here, Straits of Bosphorus right over here. And so we'll be looking at that. That's your Mediterranean seafloor. Of course, there's Spain and Portugal over here, and France up here, Italy here, and right over here is Greece. Here's the nation of Turkey, and here's Africa, North Africa. So again, there's not much water flowing from Africa into the ocean because this is the Sahara Desert right in here, not much water. There's some rainfall here, but not a large amount. And so the evaporation is much higher than the inflow from rivers and rainfall combination. Here's our nations, present modern nations that we see here, your Mediterranean Sea and what we see Adirondack Sea, and here's the Aegean Sea, and that's here's Greece here, and there's Turkey. So we can see here's the island of Crete, and here's the island of Cyprus down here. Now, this is the darker blue is the deeper regions of it, and So we got different names for some of these Ionian Sea and so forth. Okay. Here's the Eastern Mediterranean Ridge, and here's the Ionian Sea, and here's Greece, Aegean Sea, here's Turkey, and North Anatolian Fault. Anatolia is the Greek word for east. Okay, so that's east of Greece. Okay, there's your Black Sea, and the Straits of Bosphorus right here, and there's the Dardanelles Straits down here. Okay. The Black Sea had a lower sea level, and it was tied together with the Black Sea. So right here, the Black Sea was separate and began to breach through here. Apparently, there was water flowed from the Mediterranean into the Black Sea at first. So the water flowed from the Mediterranean into the Black Sea, and then it diminished. And once it diminished, then it began to flow backwards this way after it cut a channel here. So the Aegean Sea at low sea level, and then it filled this region up, and then finally, once it filled it up, if the level of the Mediterranean and the Aegean Sea rose, perhaps due to rainfall and other things at that time, as it rose, it eventually flowed water into the Black Sea over here. So here's your Black Sea. It was a freshwater lake until water began to flow out of the Mediterranean into it. And the Black Sea today is your light blue, okay? Right. So it has a lot of brine and salt into it now. It had been a freshwater lake at one time. And again, how do they know that? Because of the fossils in it. They're freshwater fossils, not marine fossils. Scandinavian ice sheet here, of course, this ice would melt. There's your Black Sea, would melt and flow down the rivers into the Black Sea. And here's your Caspian Sea over here. And of course, this, I would believe, was connected across here. As this rose sufficiently, that it was connected. Here's the Siberian ice sheet and water that flow in from these rivers to the south. As there were large lakes up in this region, we saw it in our last study last week, the last class. Look here, and we see some of the Eastern European countries. Rostov, there's two Rostovs in Russia, incidentally, and Volgograd. Grad is city. And so there's the Ukraine and Belarus and Moldova. Here are just some of your countries. There's Georgia, the country of Georgia, not the United States state of Georgia, and Armenia and Azerbaijan. And so here's some other of these countries. But there's your Black Sea and the Sea of Azov. And so these are they're joined through here, Straits of Bosphorus and Straits are broader over here. And so we have two straits coming through that where water had flowed through. So the Black Sea and the Caspian Seas, again, were joined. I believe they were joined across here. And so they were joined here. Here's your Aral Sea. It was also part of it, tied in with it as well. Now they dammed up the water coming into the Aral Sea, and it practically dried up. But they've let water flow into it again, and now it's beginning to fill up a little bit. But they nearly made it almost no water in it at all. But it was connected to the Caspian Sea at one time, which was connected across here to the Black Sea. Again, this ice melting up here flowing down the Volga River and some other rivers feeding it would have supplied the water for it. Here's the Mediterranean Sea and what they're claiming it looked like. This was dried up and this water began to flow across here to cut a channel through the Straits of Gibraltar. And of course, here's it goes over into the Black Sea over here. So that's what it looked like at one time, they're claiming. Okay. Here again is before it was breached. Here's Gibraltar across here. As it was breached and as this water begins to evaporate, it flows as rainfall. And this, of course, is your Euphrates and Tigris rivers flowing down through. There's actually the Euphrates and the Tigris both flowing the water down here into the Persian Gulf. Now, of course, this is an artist's sketch of it, but this is what they're claiming actually happened. Of course, there's a lot of ice up here that had been melting, but once the ice had melted and quit supplying water to it, it began to diminish in level through the evaporation. The colder it was, the less evaporation there would be. Heat causes more evaporation. So once it lowers and it raises the level of the oceans, which can eventually, and the ice melting and the fluvial lakes draining into the ocean, can elevate it sufficiently to breach across this isthmus right here that we see here. Now, once it breaches, they call it the Zanclean flood, and the evidence of it. The writers of this claim that you probably could have heard the roar of the water because it was flowing. Once it reached the area here, it supposedly fell like 1,000 feet or so, maybe 1,500, 2,000 feet. And so there was a waterfall where the water was flowing like 2,000 feet, dropping and hitting the floor of the ocean floor down there, the sea floor at first. They claim you probably could have heard it circle 300 or 400 miles away, the roar of it, most likely. That's what they think. And some of the writers writing about, you can just do a Google of Zanclean flood and see what they say here. That's what they're talking about here. And this water then flows out of the North Atlantic through here, begins to fill it up. And one of the writers we've already cited said it would take about 100 years or less to fill it up with water during this time. And so here's your the cell basically across here, and the flood cuts through it, incision to cut, and it flows downhill, of course, and it fills this up, and it goes over the Sicily cell, begins to fill this area over here up. So the different areas, this cell here would keep the water, and it would fill this first, and it would go over here and start filling this over here. So what we'd see is we'd see this over here, and it would give an area where we could have evaporation and increase the rainfall for a while. Once it begins to flow over, it begins to raise this level as well. So that's Gibraltar, initial drainage into it. And of course, I got this off the internet. And here's another one. And of course, this is the Mediterranean Sea here. Right over here is Israel in this region over here. Okay. Now, this is the direction of water flow. It flows this direction here, and it flows now. And at this time, it flowed into the Black Sea as it was elevated over here. It was elevated higher enough to breach it. So once it did. Now, the rainfall flows to the Mesopotamian River, Mesopotamia, Tigris, Euphrates, or Meso is between, and so it's the land between the rivers. That's what that means, Mesopotamia means. There's your Persian Gulf flowing out right here in the Red Sea here. And there's the Gulf of Suez and the Gulf of Aqaba. The Gulf of Aqaba is the only body of water that the Bible calls the Red Sea. If you study it, Ezion Geber, the city right here, was on the Red Sea according to the Bible. Here's your breach artist sketch of it, of course. Gibraltar, as it began to dump into the drained out or diminished level of the Mediterranean, dried up Sea. And of course, we've already seen the sea levels that we had lower sea levels. That's South America, North America, up here, and of course across the Bering Sea here, Bering Strait, Beringia it was called. We've seen that over here in this area in Southeast Asia as well. This was all land. Of course, that would block the flow of water through here. This would reduce the flow of water. Water couldn't flow out of the Arctic Ocean into the Pacific and affect the climate there. And the ice here would dam it up and keep it in North America. Once you get a breach of ice and there'd be a large flow of water in that, that's your Heinrich Events. Then it would close up again, and then more would flow. It'll come out again. So that's probably those 6 events there. Here's your large amount of ice over in Siberia. Notice the ice is not over here. There's not a lot of ice over here. It was here, but not over in here. So it's very interesting. I find that very interesting here. But this ice was deposited around the magnetic field of the Earth. It's centered around it, not around the geographic poles. Of course, Antarctica had a bunch of ice too, it still does. Here's a YouTube link. You can go to the time that the Mediterranean Sea disappeared. It's on YouTube. You can see it, and it's a very interesting YouTube link to go to and to view it. Let me summarize this material that I have here. The Mediterranean basin was filled with water from the tidal flood at the end of the flood. That's number one. There was a land bridge, an isthmus, across the Strait of Gibraltar, preventing water from flowing into the Mediterranean from the Atlantic Ocean. That there was a land bridge between Asia and Europe across what is now Turkey, blocking the Strait of Bosphorus and preventing the Black Sea from emptying into the Mediterranean through the Aegean Sea. Aral, Caspian, and Black Seas were all connected, with their levels being higher than they are at present time. The Mediterranean sea level began to lower because of evaporation. Water was confined to the lowest levels of the basin, and the water was very salty, or had a lot of brine, magnesium, and chloride, magnesium chloride. The land bridge across the Strait of Gibraltar Bosphorus was breached, allowing water to enter the Mediterranean Sea, which raised the level of the Mediterranean Sea. So it raised the level of the Mediterranean temporarily. And then the evaporation began again. After this, the initial surge of water from the Black Sea, the Mediterranean Sea again lowered from evaporation. It doesn't have enough water to replenish it. Too much evaporation. The lowering of the level of Mediterranean by evaporation affected the climate of the region by decreasing the rainfall, perhaps producing famine in various places, perhaps during the time of Abraham and Joseph. The Straits of Gibraltar were finally breached as the ocean levels were raised by the melting ice caps in the fluvial lakes, draining into the ocean as well. Bonneville and Gazes and other fluvial lakes. The levels of the oceans were lowered by the transfer of water from the Atlantic to the Mediterranean Sea. This sudden lowering would affect marine life such as corals and put them above the water and cause them to die. And so it would affect them. It would affect other marine life as well. These changes in levels of the Mediterranean and the oceans would have been followed by both volcanic and earthquake activity, as there were adjustments in isostasy. Adjustments in isostasy. Remember, we explained isostasy. You step into a boat, it sinks in the water a little bit due to your weight. Step out of it, it rises up out of the water a little bit. That's an example of isostasy. And they would cause both volcanoes and earthquakes from Pascal's law. Atheists have a problem with the dating of the filling of the Mediterranean basin. First, the level was at least 110 feet below sea level, according to Klotz and Courton, during the last few thousand years. Second, the atheist cloud states that the Mediterranean Basin experienced its last refilling about 51 million years before present. MYBP is million years before present time. That's what that means. But the problem with this, Berkman and Larson also agree with this. 6 million years ago, the Mediterranean was isolated from the Atlantic Ocean. The sea quickly dried up, leaving a desert basin some 3,000 meters, which I put in there is 9,840 feet below sea level, according to them. But the problem they have with this, they don't have men doing cave drawings 6 million years ago. That's their problem. The cave drawings were drawn within the last few thousand years, not millions of years. The atheistic time scale is off by 3 orders of magnitude. Now, order of magnitude is move a decimal point over one place. And so it's off by 3 orders of magnitude, off by like 1,000 to 1. And so, again, we have a problem with the atheistic view of things. We will stop at this point. Do you have any questions or comments that you want to ask of me? All right.